Hello? Hello?
Hello, sir. We are with you.
Yes, sir. The writing, I can't really understand the writing, whether that one is N or X. The F of N or X.
It's X, no M, no N here. No N here. It's X.
It looks like M.
That's how this trick is. I will try as much as
They should not make noise now.
Is that taking?
Who is making us now? Go and check your life. That is what.
You know, if you are making noise. Hello?
Hello, we're hearing you.
Please, can you mute the students so that we can hear you clearly, please? The noise is distracting.
Okay.
They should mute their mic. Anybody that wants to talk.
They should mute themselves, oh. The noise is too much here.
Okay. Can we continue?
Yes, sir.
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
This is the product. The same manner, we can also have what we call quotient of limits. Quotient of limits. To have quotient of limits, we have limit f of x over g of x as s tends to a. And this one, you can write it as limit f of x s tends to a all over limit f of x, no, g. I mean, this one will be g of s. G of s as s tends to a. Is that taken? Then this will now give us, okay. This will now give us what? Limit f of s as s tends to a is L. L, and this one is M. Is that taken? Is that taken? These are properties of limits. The next one that is important. It's important for our calculation. We call it limit of constant. Limit of constant. Let's take C as our constant. Let's say we have limits of C as S tends to A. Our C here means constant. Our C here means constant. The limit of constant will give us constant. We have to take, for example, limit of 5 as S tends to 2. It will give us 5. Is that clear? Is that clear? Okay.
No.
It's not clear. I said limit of a constant is rule, is theorem, is property. That the limit of constant, it will give constant back. I'm now use example as limit of 5 as s tends to 2 is equal to 5. That's what I've just done.
Okay.
Is there any issue? You are okay. Let's continue. Let's see how you can solve problem with the on limits. Let's see how we can solve problem on limits.
Okay.
To solve problem of limit, let's consider limits s squared plus 5s plus 1 as s tends to as S tend to 2. This is what we want to solve now. How do we solve this? We solve this by substituting directly. We solve this by substituting directly. Let's see a solution. Then limit x squared plus 5x plus 1 as x tend to 2. I say we solve directly. Any place that we see x, we put the value of 2. We have x squared, that we have 2 squared plus 5x, 5 bracket 2 plus 1. This is 1 because limit of the constant, we give that constant back. That's why we have it as 1. Then this is now equal to 2 times 2, 4. 5 times 2, 10 plus 1. The answer here is what? 15. Because 4 plus 10 is 14. 14 plus 1 is 15. Is that taking? Hello?
Yeah, yes, sir. Yes, sir.
It's a lot clearer now, sir.
But how did you get this 10? 4 plus 2 times 2 is
10.
4. Then how do you get the 10?
No, I didn't get 5 times 2. 5 times 2.
Okay, bracket, yes, 5 times 2, okay.
Plus 1, making 15. Can we proceed?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Okay.
Yes, you can proceed, sir. Well with you.
Let's consider another example. Let's consider this limit s squared minus 9 all over s minus 3 as s tend to 3. You know this, we can, if you try to substitute directly, let's try it. If you try to substitute directly, here, if you substitute here as x here, that is s squared minus 9 all over x 3 minus 3. You know x squared is 3. That 3 squared is 9. This will give you 9 over 9 minus 9, 3 minus 3. And this will give you 0 over 0. You know in mathematics, when the undefined, like this one is undefined. We cannot get solution. But we are saying here that
you said x equal to 2, and in the denomination you put 3 minus 3. Is this supposed to be?
I don't say x is equal to 2. I say s tend to 3.
Yes, s is 3.
Okay.
Yes. Okay. And we say for here, we said the function may not exist, but limit can exist. What here? S is not equal to 3. It's approaching 3. Algebraically, we can solve this problem like this. We can solve this problem like this. That is, here we can expand s squared minus 5, minus 9, s minus 3. If you know, this is different of 2 squared. Is that taken? Different of 2 squared. And different of 2 squared, we have x plus 3, x minus 3. Can someone multiply it out? If you multiply this expression out, we are going to have s squared minus 3. So, yes, we can have this. The next we do to solve problem we cancel where we have the same value. Where we have the same value, is minus 3x minus 3 minus x, x minus 3, x minus 3. This cancel this. Then the expression, let's say we write it, we have limits x squared minus 9 all over x is equal to minus 3 as x tends to 3. It now gives us what? Limit x plus 3, x plus 3. The minus, this should be minus, sorry. This should be minus all over minus 3. And this cancel this. Then we now have x plus 3. Then we now say as x tends to 3. That means if you replace where you have s with 3, we are going to have 3 plus 3 as s tends to 3. That answer is what? 6. Is that taken? Hello, everybody? Hello, everybody.
Hello, sir.
Yes,
Not
it's
quite
taken.
clear, though.
Very clear, sir.
Hello, sir. I was cut off. Oh, I didn't get the second question. I was cut off completely.
I said, can you see it on your screen now?
I've just
Can
seen
you
it.
see
I
it
don't
on your
even.
screen?
I've just seen it now. I was cut off.
What I'm saying that if you have this function, if you substitute directly, you are going to have 0 in the numerator and 0 in the denominator. Because if you put s directly, we have s 3 squared is 9. 3 here, 3 minus 3 is 0. 3 squared is 9. 9 minus 9 is what?
0.
0. 0 over 0. And since the denominator is 0, we say the function is not defined. It's not defined. We say the function is not exist, but limit can exist because limit is approaching. Then we now expand algebraically. Since x squared minus 9 squared, and in expansion of difference of 2 squared is s plus 3 minus s plus 3 brackets s minus 3. If you multiply the 2 out, we are going to have s squared minus 9s all over 3 s minus 3. Then we can see minus can cancel minus here. Then we left with s plus 3. Is that taken? We left with s plus 3. Then since that what is remaining as s tends to 3, we now replace where we have first with 3. Will now be 3 plus 3, which is 6. That's the solution. Is that taken? Okay. Can we consider more example? Or let's
Just
pick
a
Yes,
question.
one more example.
Now, one more example.
No, I have a question, please.
Okay, I'm listening.
Okay. My question is why
Hello, I'm
was
listening.
okay, why was it just the x raised to power 2 minus 9 that was expanded? Couldn't we have also expanded the x minus 3?
You know, s minus 3 is in its simplest form. It cannot be expanded. It cannot be expanded. It's in its simplest form. It cannot be expanded.
What? Are you there, sir?
I'm
Hello?
here.
Okay.
Yes.
Is it because it is limits? That is why the x minus 3, the 3 minus x minus 3 cannot be expanded.
No, in any way it cannot be expanded. It cannot be expanded in any way, in any form in mathematics. It cannot.
Okay.
Is that
Let's
taken?
consider one. Yeah, it's taken. Let's consider another example now. One more example, sir.
Okay. Okay, let's look into your course material. Okay, let's look into your course material.
Okay.
This example 8, can we solve this example 8?
Example 8. Okay.
Okay. Are we there?
Yes, yes.
Can someone read out the question for me?
Question 8 says, find the limit if possible.
If possible.
Find limit x is equal to 2.
X is equal to 2.
Okay. Let's consider that.
3 all over.
Let's consider that minus x minus 2. Let's consider that. Let me get to my whiteboard. Okay, can you see? This is my whiteboard. We want to find the limits of 3 over s minus 2 as s tend to 2. Is that taken? You know here, this s minus 2, like I said earlier on, that it cannot be expanded in any form in mathematics. What we just do here, we substitute directly to the value of what? X. The value of x here is 2 minus 2. And this one gives us 3 over 0. And 3 over 0 will give us what? Undefined. It's undefined, it's not even, it's undefined because we don't know the size. It's undefined, or simply represented by infinity. It's undefined. There's much we can do on this one. Then, if we even test from the limit of right and limit of x, from limit of right, we see the same thing. We are still going to have the same number. This one means left is also this infinity. If it takes from the limits of right like this, I'm coming. And we can see it's what also undefined. We see here the limit of this function, limits of 3 over 3, I'm coming, 3 over 2s minus this as x to 2 is not, does not exist. Does not exist. Is that taken? Is that taken?
Yes, sir. Yes, sir.
Okay. Let's consider exam one more. Let's consider one more. Look at this beautiful example. Find the limit. Find the limit of x squared minus 8 all over 2. This is a nice example that we can do. It's very nice. Can we do that? Can we do that together? Hello?
Yes,
Yes,
sir.
sir. Yes, sir.
Go ahead, sir.
We said go ahead. I said, can we do it together? I want yourself to do it.
Yes,
Yes, sir.
do it together.
Okay.
The things when I know they know assign. I will best for them.
Okay. Let's do it. Okay. Let me introduce this with you. Next we have limit x squared plus x plus 6 all over x plus 3 as x tends to minus 3. Can we solve this? You know, if we substitute directly, we are going to have, if we substitute 3 here, square plus 3 plus 6, then we are going to have minus 3. It's minus, sorry. Minus 3. We have minus 3. And this also, sorry. This also minus 3. You get it? This will be minus 3 plus 3. And this one will give you 9. Do you get it? 9 minus 3 plus 6. Is that taking?
Yes, sir.
Plus 6. Then this will be 0. Is that taking? Why? Minus 3 plus 3.
Minus 3.
0. We said this is what? Plus 3 is 0. That means we cannot solve this one directly. The limit exists. We now solve it by algebraic form. Let's do algebraic form of this. Can someone?
9 plus 3 minus 3.
Huh? I'm listening. Stop. Elijah, you raise up your hand. Elijah. Okay. We can factorize this. Factorization of this is 2 is 3 plus x minus 2. Can someone get the factorization for me? This factorization of it. Then we now say all over x plus 3. That taking.
I'm confused, sir. I'm confused.
How, where do you confuse?
Because I don't think this is not.
You say you, not me.
You said solve it in algebraic form now. That's what you said. I thought you said you should solve it in algebraic form now.
Yes,
Yes, I said
first
so.
of all, expand the equation. So that's what he's trying to do now.
You know, if you solve it directly, the limit will be undefined. But we have to factorize it. We have to find the factor of x squared plus x plus 6. That's what we are doing. And if we expand this, we get this one back. I hope you people have done enough work in your factorization method. It's very, very important. Then this, cancel this. Then we have s minus 2. Then as s tend to minus 3. Then when we have x, we put minus 3, minus 2. This will give you what? Minus 5. That's the solution. Is that taking? Hello? This 3. Hello?
X is minus 2.
That is s minus 2, and s is minus 3. Minus 3 minus 2 is minus 5. Can we proceed?
Yes, sir. Yes, sir. It's cleared.
It's cleared.
It's clear.
Okay. This one will now lead up to the problem that we want to consider. It will lead up to the problem we want to consider earlier on. Okay, the problem we want to consider is limit s raised to power 3 minus 8 all over x minus 2 as s tends to 2. Is that what we said we want to consider together?
Yes.
Like this, if you stop the 2 directly, 2 raised to power 3 minus 8 all over 2 minus 2. This will give you 0. This will give you 0 over 0. Because 2 raised to power 3, can someone help me? 2 raised to power 3 is what?
8, sir.
8 minus 8.
0.
Yeah, that's why we have 0. You know, we cannot stop this like this. But you can think of a way that is s minus 2 is a factor of s cubed minus 8. Understand what we call non-division. This non-division we want to do. You want this power of this. That means you have to multiply this side by 2 squared. 2 squared times x will give you x what? X squared. Times minus 2 will give you 2x squared. Is that taking? This, okay, I made a mistake. This x squared times x will give you s cubed. Wow, sorry. This will give you, sorry, let me try to minimize this space I have here. This s squared. Then we now subtract, if you subtract s cubed minus s cubed, we have 0 here. Is that taking? Then it's ordinary 8. We can go with this. Minus, this place should be minus here, or what we call invisible minus. Let's just put it so that you people can get what I'm saying. Okay. We are multiplying this one. We multiply this by s squared. We say s squared times x will give us s cubed. S squared times 2 will give us 2s. We now put minus. here. We now say x cubed minus x cubed is 0. Then this minus times minus here will give us plus. That will give you 2x squared minus, because 8 here, we bring the 8 down, minus 8. Is that taken? What will we do? To have this, we are going to multiply by 2x. Is that taken? This will now give us, oh, I made a mistake.
Yeah.
If we multiply it by 2x,
Is it come?
2x, this will give 2x. 2x times x will give us 2x squared. 2x times 2 will give us 4x. Is that taken? Then we now multiply, we now do the minus. This will now give us, this will give us 0 minus 4x minus 8. Then what can we do now to get this? To get this, then we multiply by 2. We multiply by 4. That will now have 4x coming. Is that this one? Hello, this will now give you 4x. This will now give you what? If you turn this, will give you plus 8. Is that taken?
Are you there, sir?
Okay. Then we put minus here. Minus minus 4. You people are not with me.
It's not clear, sir.
Hello?
We are with you, sir.
It's not clear. I don't even understand.
It's not clear, sir.
Okay. And that means you cannot do division right from your secondary school. Let's do it. Let's start it again. Let's start it again. We want to find this. We want to use this as want to use it as a factor of this. And to do this, we use what we call non-division, which will give us x minus 2x. Divide by this as division. Do you get it? Then to make this x equal to this, we must multiply it by x squared. That's why I say s squared here. We multiply it by s squared. That's why I say s squared here. Multiply s squared by x cubed. Multiply s squared by 2 minus 2 minus 2 minus 2x squared. Is that taking minus 2x squared? Then in order to reduce, we are doing division. In order to reduce this, we say minus 3 minus x. 3 the x squared, x cubed minus 3 minus x cubed. The x squared by 3 minus x squared by 3. This will give us 0. Is that okay? This will now become plus x squared, because minus times this will give you plus. And this will move down to 8. Then we multiply by 2x. We will now multiply this by 2x times s. We have 2x squared. 2x times minus 2, we have minus 4x. x. Is that taken? Then this will give you minus 2s squared minus 2s will give us 0. Then minus times this will give us plus. Minus times 8. Is that taken? Then what we now do here to give us this, we multiply them by 4. This will now give you 4 times x, 4x, 4 times minus 2, minus 8. If you do this one, we are going to have 0, 0 here. Tell me, this expression s plus this, s minus 2 bracket s squared plus 2x plus 4x. Can you see? Then that's the fact back to our main equation. Our main equation is this. Is this limit s cubed minus 8 is equal to over s minus 2 as s tends to 2. This one is now replaced by x minus 2 bracket s squared plus 2s plus 4 all over s minus 2. Is that taken? This we cancel this. That means we are left with this. We are left with what? Limit s squared plus 2s plus 4. Let me write it properly. Limit s squared plus 2s plus 4 as s tends to 2. Then we can now substitute directly. This will now be 2s squared plus 2 times 2 plus 4. Then we have 4. 2 squared is 4. 2 times 2 is 4. Are you getting me? It's 4. That's 4 plus 4 plus 4. And this gives us 12. Is that taking? Hello?
So we are with you, sir.
Yes, sir. Yes.
Yes, it's
Is that taking?
Yes, sir.
Okay. We've studied limits and we are able to solve a problem on limits. I will encourage each and every one of us to work on the limits before we meet in the next class. Let you people, as I'm solving, you people, you put barrel down and solve, because mathematics is about solving. Are you getting me?
Yes, sir.
And I want to encourage each and every one of us to watch the instructional video sent to you. Video sent to you. I always send it to your mail, and you can also watch it with our content management. If you go to your study center, ask the ICT how you can also update online. Even the lecture today is online. You can also watch the lecture, this presentation online, live and direct. You know, I want to employ you tomorrow to join me at the same time. Can you do that, all?
Yes, sir.
Yes, yes.
You join me tomorrow.
Yes, sir. Yes, sir.
Tomorrow, we are going to consider what we call continuity of function or continuous function. Is that taken?
Yes,
And
sir.
I want if there is a question, you can ask me before we call it again, before we round it. Let me remind you, we have class activity on the instructional video. I want everybody to attend to the class activity. Is that taking?
I did not hear you, sir.
Hello. I said we have class activity on the instructional video sent to you tomorrow. Yesterday. Please watch it. Someone said what time tomorrow? It's 3 p.m. 3 p.m. tomorrow.
Tomorrow.
Where you said, where can we
Same
watch
time.
this?
Your mail is in your mail.
Meeting code.
I also send this one to you. It's in your mail. Any question for me before we call it or we round it up?
Everything is clear. Yes, sir.
Everything is clear.
It's clear.
Am I talking to Oji? Oji what?
No.
Hello?
Everything is clear.
Everything is clear. Please work hard. Mathematics, not everything is clear. Try to work on your own. At
Okay,
your
sir.
own space, at your own time.
Okay, sir.
We see
Thank you very
tomorrow
much, sir.
for the taking. How many of you taking MTH103? Okay.
Sir?
How many of you taking MTH101?
No, this
No.
is second semester student.
Okay. Thank you for listening. To meet in the next class.
Thank you very much, sir.
Thank you, sir. Bye-bye. Have a
Thank
lovely weekend.
Dr. Akeem Babatunde.
See you tomorrow.
Bye.
Take care, sir.
Please. Don't peel this again. I'm not peeling me. Shut up. I'm gonna give you. Go and bring one. And the last. You cannot take another one. I'm not going to take tomorrow. Don't tell me that. Oh God. Bring one, let me test it. Don't do this. We don't down. Turn his back and bring that line of chicken for me. How is this it? What did you want to take? It's not per salary. I want to borrow money to buy them. You want to finish it.